Hey there guys, welcome to the video. My name is Pushpinder Gill. In this video, we're going to be talking about what all different values will these functions are going to take in different quadrants. So we have four different quadrants here. That is, I'm just going to start with our diagram here. That is this diagram in which this was A comma B and this was angle X. And we had the value of sine x to be equal to b, and we had the value of cosine of x to be equal to a, right? So this is something that we had. Now let's actually try to find the values of these functions in different quadrants. So I'm going to say first quadrant, second quadrant, third quadrant, and fourth quadrant. Now I'm just going to draw these lines here like this. And here we go. So I'm gonna start first initially with the value of sine x, right? So let's start with the value of sine x. So this is sine x. Now sine x is actually dependent upon b. Now sine x will actually go all the way from here till here. Now the value of b over here, this is something which is 1 comma 0. So the value of b over here is 0 and the value of b over here is 1. So sine x in the first quadrant will take values all the way from 0 till 1. So it will go from 0 to 1 and it is going to increase, from 0 to 1 you increase. And over here from 1 all the way it's still going to come down to 0 because b is the y coordinate. As you can clearly see, the y coordinates are these which are on the right hand side. So from 1 till 0 b is going to decrease and so is the sine function. So from 1 till 0 it is going to decrease. Now what happens in the third quadrant? In the third quadrant from 0 all the way it's gonna go till negative 1. So from 0 it's gonna go till negative 1. From 0 all the way till negative 1, which means again it is going to decrease. And in the fourth quadrant, so this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. And the fourth quadrant is going to go from negative 1 to 0. So it's going to go from negative 1 all the way till 0. So let me just put arrow mark here. That means it's going to increase. So this is the value of the sine function here. Now let's actually understand how does the cosine function behave. That is going to happen from the value of a. Now the cosine function, that is cosine of x, again it's going to have it's going to be from the value of a. So it's going to go from 1 all the way till 0 here. That means it's going to decrease. Then from 0 all the way till negative 1, as you can clearly see, from 0 to negative 1. That means 0 to negative 1, which means it's still going to decrease. Then it's going to increase from negative 1 till 0. So it's going to increase from negative 1 till 0 here, which means from negative 1 till 0 in the third quadrant, which means it's going to increase. And then from here, from 0 all the way till 1, that means from 0 till 1 it is going to increase. Now once we have the sine function and the cosine function, we can actually know everything about the tangent function as well. So let's try to find everything about the tangent function. Now what is tangent of x? That is, tangent of x is equal to sine of x divided by the cosine of x. So what is tangent x? That is sine of x divided by the cosine of x. Now we're going to actually find out the values from these things here. Now the minimum possible value of sine of x in the first quadrant is 0 and the minimum possible value of the cosine function is also 0. So 0 divided by 0. Oh, okay. It's a little tricky here because tangent of x is equal to sine of x divided by the cosine of x. Now if I want the maximum possible value of tangent of x, I need the maximum possible value of sine of x and the minimum possible value of cosine of x. So if I need the maximum possible value of tangent of x, I need the maximum possible value of sine of x and the minimum possible value of cosine of x. So what is the maximum possible value of sine of x? That is 1. And what is the minimum possible value of cosine of x? that is actually 0. So 1 over 0, it's going to be infinite, right? So the maximum possible value of the tangent function in the first quadrant, it's actually going to be infinite. And you can clearly see that tan 90 is also infinite. And the minimum possible value, it's actually going to be 0. Now why it is going to be 0? Because the minimum possible value would be the minimum possible value of tangent function is going to be the minimum possible value of the sine function divided by the maximum possible value of sine function, which is actually equal to 0 by 1. So that is 0. And since we're going from 0 to infinite, the value is actually increasing. Now same thing we're going to do over here, that is we're going to divide this by this, 1 over 0. So we're going to start from in the second quadrant, we're going to start from negative infinity, right? Now why negative infinity? Because we want, as you can see, that sine of x is actually a positive number and cosine of x is a negative number. So it's going to be negative infinity. That is going to be the minimum possible value, which again you can clearly find out by the maximum possible value, the minimum possible value of sine of x, which is 0, divided by the maximum possible value of cosine of x, which is again 0. And 0 by 0 is infinity. And from infinity, we're going to go till tan pi, that is here, which is again 0. Right? Now why is it 0? Because for us to find out the maximum possible value, we need the maximum possible value of sine of x, which is 1, over the minimum possible value, which is negative 1. But 1 over negative 1, it's negative 1, which is tan 4, which is going to be this angle here. But we're interested in finding out this angle. This might not be a maximum or minimum possible value, but this over here, the value is 0. Similarly, in this case over here, in the third quadrant, if we find out in the third quadrant, it will start from 0, right? As you can clearly see that it ends at 0, so it starts at 0. So from 0, it is going to go again to an infinity, right? Which is again an infinity, and it's going to start from this infinity again. So once we change it, it becomes to negative infinity, and again it is going to end up till 0. Now over here we're going from negative infinity to 0, which means in the second quadrant it is actually increasing. In the third quadrant we're going from 0 to infinity, which means again it is increasing. And the third quadrant we're going to negative infinity to 0, which means again it is increasing. So the tangent function is an ever increasing function. So you can clearly see that it is increasing. So these are the various values or the various ranges of the value of sine x and cosine x and tangent x. Now let's try to find it for the cotangent x. Now for cotangent x, you can clearly see that cotangent x is an inverse of tangent x. So if the maximum possible value in the first quadrant for tangent x is infinity, minimum possible value would be infinity, and maximum possible value would be 0. It's going to decrease. If 0 is here, 0 will come here and negative infinity will come here. That means this is again going to decrease. It's going to go from infinity to 0, again going to decrease. It's going to go from 0 all the way till negative infinity, which means this is again going to decrease. Pretty simple, because tangent x is actually the inverse of cotangent x, or cotangent x is the inverse of tangent x. So these are going to inverse. Now that is there. Now let's go ahead and find it for cosecant x. Now what is cosecant x? Cosecant x is nothing but the inverse one reciprocal of sine x. Now if the value of sine x is actually equal to, so I'm just going to do it in the next here. If the value of sine x is equal to 0, or the value of sine x is equal to 1, then 1 over sine x, it's going to be equal to 1 over 0, which would be infinity. And 1 over sine x in this case is going to be 1 over 1, which is going to be equal to 1. So if sine x is 0, cosecant x is infinity. If sine x is 1, cosecant x is also 1. So if sine x is 0, cosecant x is infinity, and sine x is 1, cosecant x is 1. So 1, 1, 0, infinity, 0, infinity, negative 1, right? So negative 1, it's negative 1. And negative 1, it's again negative 1. and infinity, that means it's again infinity. But we have to take care of the signs of infinity as well, right? So as you can clearly see that the sine and the cosine function are totally reciprocal of each other. So if this is an increase here, this would be a decrease here. This is a decrease here, this would be an increase here. If this is a decrease here, this would be an increase here. And if this is an increase here, this is going to be a decrease here. So you go from you go from infinity to 1, you decrease. You go from 1 till infinity, you increase. You go from negative infinity to negative 1, you increase. And you go from 1 till negative infinity, again you decrease. So this is about the value of cosecant of x. The final thing that's left, which is the value of secant of x. In secant of x again, which is the inverse, the reciprocal of cosine of x, if this is 1, this is going to be 1. And if this is 0, this is going to be infinity. If this is 0, this is going to be infinity. From 1, this is going to be minus 1. And if this is minus 1, this is going to be negative 1. This is 0, this is going to be infinity. If this is 0, this is going to be infinity. This is 1, this is going to be 1. Right? And if this is decrease, this is going to be increase. This is decrease, this is going to be increase. This is increase, this is going to be decrease. And this is going to be decrease. So you go from infinity to 1, you decrease. You go from 1 till infinity, you go from infinity to negative 1. You cannot increase, so you'll go from negative infinity to negative 1, which means it would be an increase. You go from negative 1 to negative infinity to decrease, and you go from infinity to 1 to decrease. So that is something that completes a table of different values of the sine function, cosine function, and tangent function, and all the trigonometric functions. So this is something that kind of sums it up. So, I suppose you've understood this one here, guys. Now let's go ahead and based on this information, let's try to create graphs for different functions. So let's create a graph for y is equal to sine of x. So if I say y is equal to sine of x, and I say this is the y axis, and this is something that we have our x axis, right? And this is something which is 0, and we have this as pi, and we have this as negative pi, we have 2 pi, and we have negative 2 pi, then we have 3 pi, and then we have negative 3 pi. Now you know that sine, something that we know that sine 0 is 0, sine pi is also 0, right? Something that we already know that sine of n pi is 0. So sine, all the values of sine function at this value here are going to be 0. And if I kind of see, as the value of sine increases, as the value of x increases, the value of sine increases, and it attains a maximum value right here, that is at pi by 2. So as you know that sine of pi by 2 is actually equal to 1. So it attains a maximum possible value. I'm sorry, this is not pi by 2. This is 1, which is the value of y, and this is pi by 2. So it attains a maximum possible value at pi by 2, and that maximum possible value is equivalent to 1. And again it drops, and again it comes down to 0, right? And as you know, in the second quadrant, something that you can know from here, in the second quadrant, the value of it's in the first quadrant, it increased from 0 to 1, and from again in the second quadrant, it's going to go down from 1 all the way till 0, which actually has happened here, because if I kind of break this up, this is something which is the first quadrant, and this is something which is the second quadrant. And again from here, this is the value of 3 pi by 2, for which the value is going to be negative 1, and this is how the function is going to go, because this is the third quadrant and this is the fourth quadrant. In the third quadrant, the value of this, it's going to go from 0 to -1, as you can clearly see, from 0 to -1, and the fourth quadrant from -1 till 0, and the fourth quadrant from -1 till 0. Now in the previous videos, you must have learned that the value of sine of x is equal to the value of sine of 2n pi plus x. That means the function repeats itself after every value of 2 pi, which means from 0 all the way till 2 pi, the function it's going to repeat itself. So from here and all the way from 2 pi till 4 pi, the function is going to be exactly the same. Similarly over here, the function is going to be exactly the same. So this is how the sine function it's going to go. So from pi to 2 pi, it's like this. From 2 pi to 3 pi, it's like this. So that is exactly the sine function is going to behave. It's like a wave. Now let's go ahead and understand the value for the graph for the cosine function. Let's just get the yellow color. I like it. So y is equal to cosine of x. Now how is the function for cosine of x going to behave? Let's try and understand that. So let's suppose this is 0. Again we have pi, we have 2 pi, we have 3 pi, and then again we have -pi, we have -2 pi, and then again we have -3 pi. Right, so this is how the function is. Now you already know that the value of cosine of 0 is actually equal to 1. So the cosine of 0, it's 1, and the value of cosine of pi, it's equal to 0, right? So the value is it goes down here, and this is 0. And again the same happens for this as well. That okay, just a little modification. The value of cos of 0 is 1, and even cos of pi is 1, but the value of cos of pi by 2, that is let's say cos 90, is 0. So this, it's not going to be like that. Let me just erase everything and redo it. So it's going to be 0 at pi by 2. So this is pi by 2. So this is going to be 0 at pi by 2, and again it's going to be 0 at -pi by 2, like this, right? So this is how it's going. And again it's going to go down, and it's going to come up again, and it's going to be 0 at 3 pi by 2, and it's going to be 0 at -3 pi by 2. And since again we know that the value of cos of x is equal to the value of cos of it kind of again repeats itself in a pattern, and that pattern, it's going to be repeated like this, right? So I suppose you're understanding this point here. Again, in this case, from 0 to pi, it's the first quadrant. 0 to pi by 2, it's the first quadrant. Pi by 2 to pi, it's the second quadrant. This is the third quadrant, and this is the fourth quadrant. So again, the function is going to repeat from 0 to 2 pi, or you can say x plus 2 pi n. That means the function is going to repeat itself, and this will actually be the function for cosine x. And this is actually, we can actually measure in our data. See, for first quadrant, the value of cos x goes from 1 till 0. So you can clearly see that it's going from 1 till 0 in the first quadrant. From the second quadrant, it goes from 0 to -1. So this is something which is -1. From 0 to -1. So you can clearly see it's going from 0 all the way till -1. And this third and fourth quadrant, it's something we can actually verify here. So this is the function of cosine x. Now this is not exactly the same as the function of sine x, because if I kind of overwrite the function of sine of x on this, if I write the function, overwrite the function of sine x on this, this is how sine x it's going to look like, right? So this is how sine x is going to look like, and you can clearly see that cosine of x is not the way it is, right? So I suppose you're understanding this point here, guys. So the sine and cosine function are going to be something like this, right? So let's go ahead and find the graph function for y is equal to tangent of x. Now before I draw the graph, I would want to know what are the different values that this can take in the first quadrant, second quadrant, third quadrant, fourth quadrant. The first quadrant goes from 0 to infinity. In the second quadrant, it goes from negative infinity to 0. In the third quadrant, it goes from 0 to infinity again. And the third quadrant, it goes from negative infinity to 0, right? So the first quadrant goes from 0 to infinity. Second quadrant, it goes from negative infinity to 0. Third quadrant, it goes from 0 to infinity. And the fourth quadrant, negative infinity to 0. Now, if I kind of draw the graph again like this is the y coordinate, this is the x coordinate, and this is 0. And I'm going to say, let's say this is pi by 2, and this is pi. This is 3 pi by 2, and this is 2 pi. Right? Similarly, over here, negative pi by 2, and we have negative pi, and we have negative 3 pi by 2, and we have negative 2 pi. Now, in the first quadrant, which is actually from 0 to pi by 2, it goes from 0. So, in the first quadrant, it goes from 0 all the way till infinity. So, if let's suppose this is the kind of the line for the first quadrant, it's gonna go from 0 all the way till infinity. So it's gonna go till infinite. So that is how the line is going to go. It's gonna go reach up, right? So that is something that happens in the first quadrant. In the second quadrant, that is from pi by 2 all the way till so that is from pi by 2 all the way till pi. All the way till pi. That is gonna go from negative infinity, which means it's gonna come out from negative infinity, and it's gonna touch the value 0 when it hits pi, right? So sorry, just a little sec. Okay, so it's gonna go from negative infinity and it's gonna touch pi here, right? So that is what happens in the second quadrant. In the third quadrant, which is this is something which is from pi by 2. This is something which is from 0 to pi by 2. This is something that is from pi by 2 till pi, and this is something which is from pi to 3 pi by 2, right? So that is from pi to 3 pi by 2. That is from 0 to infinite. So from 0, it's gonna go and touch infinite like this. So that is for the third quadrant. In the fourth quadrant, from 3 pi by 2 all the way till 2 pi, is gonna go from negative infinity all the way till 2 pi. So it's going to go from negative infinity here all the way till 2 pi. Now, as you know that trigonometric function, this function again, it's cyclic. Again, for the negative one, it's going to be completed like this, and you're going to have these lines here. That means for even for negative pi by 2, it's going to start from positive infinity. It's going to touch 0, and this is how the function is going to be. So this is the function of tangent of x. Y is equal to tangent of x, right? So I suppose you're understanding this point over here, guys. So suppose that is understandable. It's gonna be like this, right? Yeah. Okay, so this is the function of tangent of x, right? So just two more to go. Now let's go ahead and do the function of secant of x. Now again, if I kind of find out the function of secant of x in the first quadrant, it's gonna go from 1 till infinite. In the second quadrant, it's gonna go from negative infinite till negative 1. In the third quadrant, it's gonna go from negative 1 all the way till negative infinite, and the fourth quadrant, it's gonna go from infinite till 1. So if I kind of draw this, the graph here, this is the x-axis, this is the y-axis. Let's say this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. Right? So let's actually just do it for these four quadrants here. Now in the first quadrant, it goes all the way from 1 to infinity. So let's say this is 1. So it goes from 1 till infinity in the first quadrant. So this is the first quadrant. So it's going from 1 till infinity. And in the second quadrant, it's going to go from negative infinity to 1. In the second quadrant, it's going to go from negative infinity all the way till -1. So let's say this is -1. It's going to go from negative infinity all the way till -1. And in the third quadrant, it's going to go from -1 till infinity. So it's -1 here. And in the third quadrant is going till negative infinity. And in the fourth quadrant is going from infinity to 1. Right? So it's going from infinity till 1. So in the fourth quadrant, it's starting at infinity, but it is reaching 1. Right? So if we kind of replicate the same stuff on the left hand side as well, if we replicate the same stuff on the negative side, so this is something we have like this here, in the negative side, it's gonna go like this, and over here again we're gonna have it's starting from this point all the way till -1, and then again, and the function will repeat itself. So I suppose you're understanding this point over here, guys. Let's reach our last function, which is y is equal to cosecant of x. Now what exactly y is equal to cosecant of x is going to do for us? Again, we're going to have 4 quadrants with us: first quadrant, second quadrant, third quadrant, and fourth quadrant. And cosecant of x goes from infinity to 1, and from here it goes from 1 till infinity. In the third quadrant, it goes from -infinity to -1, and the fourth quadrant, it goes from -1 till -infinity. So let's kind of redraw this again, something like this. We have the x coordinate, we have the y coordinate, and we have the value of pi by 2, we have the value of pi, we have the value of 3 pi by 2, and we have the value of 2 pi, right? So in the first quadrant, it goes from infinity till 1. So it starts from infinity and it goes till 1 in the first quadrant. So it starts from infinity and it goes till 1 in the first quadrant. The second quadrant from 1 till infinity, so 1 from 1 till infinity. In the third quadrant, from -infinity all the way till -1. So let's say this is -1. And the fourth quadrant from -1 all the way till -infinity. So if we redraw the same stuff on the left hand side as well, because the function is going to repeat itself, this is how this is going to be. So over here, now since we know that sine of -x is actually equal to negative of sine of x, so on the left hand side, the function it's actually going to start from here. So the value from 0 to -pi by 2, it's going to go from -infinity till -1, and like this. So this is going to repeat like this, right? Because sine of -x is equal to negative of sine x, right? So this function will get inverted here, and this function will go at the top here, right? So because sine of x is equal to negative of sine x. Why didn't it happen in the previous function? Because as you know that cosecant of sine -x is actually equal to cosecant of x. Something that we established in our previous videos. You should watch those videos if you haven't watched them, right? So that is about the function of y is equal to cosecant of x. Now we're left with one more function, one last function, that y is equal to cotangent of x, that is 1 over tan x. Now if we see for cotangent of x, again first quadrant, second quadrant, third quadrant, and fourth quadrant. In the first quadrant, it goes from infinity till 0. In the second quadrant, it goes from 0 to -infinity. In the third quadrant, it goes from infinity to 0 again. In the fourth quadrant, it goes from 0 to -infinity. So if we kind of redraw the same thing again, right? This is something which is 0. This is the x-axis. This is the y-axis. This is pi by 2. This is pi. This is 3 pi by 2, and this is 2 pi, right? Again, we have -pi by 2, and we have -pi, we have -3 pi by 2, and we have -2 pi. Right? So from the first quadrant, it's going to go from infinity till 0. So in the first quadrant, it's going to go from infinity till 0. So it's going to go something like this. And in the second quadrant, it's going to go from 0 to -infinity. So it's 0 is going to decrease to -infinity. In the third quadrant, it's infinity to 0 again. In the third quadrant, it's infinity to 0 again. In the fourth quadrant, it's 0 to negative infinity again, right? So this is going to repeat itself like this on the left hand side as well. This is how it's going to be. Now, one thing you have to make sure over here is that tangent of x is actually equal to sine x over cosine of x, right? Now, as if I want to find the tangent of negative x, it's going to be sine of negative x over cosine of negative x. Now, this is going to be equal to negative of sine x over cosine x, which means tangent of negative x is equal to negative of tangent x. It's because of this negative sign. So over here, this function, it's gonna go a little like this. So in this, it's gonna go like this here, and it's gonna start like this here, right? Because this will not be true, because tangent of negative x is equal to negative of tangent x. This upper line is gonna go as a lower line when we go to the left hand side. So this is how the function of y is equal to cotangent of x, it's going to look like, right? So I suppose you're understanding all the graphs over here. So we started with the sine graph. This was the sine graph, which it's from 0 to pi, from pi till 2 pi, it goes like this. The cosine graph, it goes from pi by 2 till negative 3 pi by 2, or pi by 2 till positive 3 pi by 2, and so on. The tangent x goes these lines. This was secant x that we did, right? So that is the secant x. Suppose you've understood this one as well. So then we did the cosecant x, and we did the cotangent x, right? So I suppose you're understanding this point over here, guys. Thank you very much for watching this video, this would be the web address to explore more about us, that is perfect-scores.com. This would be the Facebook page to give us your valuable like, and you can give us your valuable feedback on perfectscores89@gmail.com. So this would be about the video, guys. Thank you very much for watching, and I will see you in the next one.